Hello, and thanks for joining me. Well, look what followed me home the other day. Actually, this and a lathe followed me home. Got a pretty good deal on them. I need it like a hole in the head, but I just couldn't pass it up. It's a really unique drill press. It's a table model. Here, let's take a little closer look at it. Well, there it is. I've got it on a roller stand so that I can roll it outside and clean it up. But it's 32 degrees out there today, and it'll probably warm up pretty soon, but it's too cold to clean it up right now. So, first thing we got to do is build the drive on it. And the drive, there's some bolts down there at the bottom, bolt holes, and that's where the drive is going to bolt on. It's a big challenge on this drive getting the speeds right, because right there is a fixed 4-inch diameter drive pulley or driven pulley on the spindle. So I've got to design all the drive back here on the back side where I can change speeds. Here's what I came up with. This hangs off the back of the drill press, and that's a 1750 motor going to a 12-inch pulley there. And these step pulleys I'm going to make out of wood, and that's 12, 6, and 3-inch. And right there bolts to the back. But that's the piece we're going to make first. But I made a large CAD drawing. Billy at Knox Machining called it CAD, but he was referring to cardboard aided design. You'll see what I mean here in a minute. Okay, there it is, printed to scale. Sitting right where it will be mounted on the drill press. It's a pretty good way to do that. Printed it full size and then taped it together and put it on a piece of cardboard. Good way to double check sizes, make sure it fits. Here's what I got with the drill press, and we will restore this at a later date. This is a Harding Cataract lathe. I'm guessing about a 1920 or 30 model. It's a precision lathe. It's not in super good shape, but it's in decent shape, mostly cosmetic. And here's what came with it. Maybe a later model than that. I'm really not sure when it was made. There's a couple of cross slides, faceplate, a 4-jaw chuck. There's the tail stock. It's been a pretty bad shape. That's going to be a challenge to fix up. Got a couple of big reamers and a couple of extra vices in with the mix. That vise right there is going to be a video. It's a quick release vise. It's got some broken castings on it, but we're going to fix that. Anyway, let's get started on this drill press. Okay, that's my 2 uprights, and that's going to be fastened to the back of them on each end. And I want everything to be lined up. You can see I got a little bit off out of alignment there. It's pretty close down here. I got bolts in it and a pair of vice grips there just for some added insurance. And I'm going to clamp this in here. I'm putting a round pin here so that it's flat to this jaw. Now, technically I should be, well, I'll tell you what. You're always supposed to work off the back jaw. So let's flip that over and work off the back jaw. There we go. Now I want to mill this. To give me a machine surface to attach to here. If that didn't make any sense, it'll be clear in a little while. Yeah, I don't have the right bolts, but I'm not going to get some shorter bolts. Can't ask for a better fit than that. Well, I like it. Give this thing a little test run. Very crude test run. Cool. Looks good to me. Well, let's talk about what direction we're going here. This is going to be a cone pulley, a wood cone pulley on a sliding shaft. I'm going to drill a hole in them, cut them to rough diameter, and glue them together. It's kind of unconventional. It's going to be a sliding pulley. And sliding pulleys work good, but they have wear issues. But I think I've got a good way to do this. Take a look at the animated CAD drawing I made here. You notice the wood has a brass bushing in there, and the two 1/2-inch bars are what's actually driving the wood pulley. And then there's a little lever that you can pull out that sits in a groove on the shaft to stop it from sliding back and forth. That's a 1-inch shaft, and the step sizes are 4-inch, 7-inch, and 10-inch. Anyway, that's the direction we're going. So I'm going to drill these and cut them to rough size, and then turn them on my CNC lathe. Looks like I got good squeeze out everywhere except right here. Actually, there's a little bit coming out now. Yeah, maybe a little bit right there. I'm done sanding it, and I'm going to put a coat of black stain on it. I used it on a speaker cabinet a while back, and I really liked it. Well, I got this thing chucked up in my forge on my metal lathe, and I'm going to get sawdust all over my lathe. I'm going to try to bore it for some bushings with a boring bar all the way through, and I don't know if that'll succeed or not. First, I'm going to, this is a Forstner bit. Well, my battery went dead, so I'm not sure what I missed recording, but I made an extension for my Forstner bit, and we're going to go all the way through with it. Alrighty. Good deal. That's 1.1/8, and I need to be 1.25 inches. But I also need to make a ledge for this bushing. I'm going to do that right now before I bore it. Wow, I like it. I like it. I think it's going to work out good. Well, I still need to drill 2 through holes in the pulley and make these 2 things. And cut some grooves and keyways and quite a bit more to do. I think that wraps it up for today, and thanks for joining me, and be sure and subscribe. And ring that bell. Yeah, I like it.